substances?
No, separation of substances is a different chapter. Sorting material is a different chapter. Okay, answer some questions from separation of substances to me then. Okay.
Okay.
So first of all, do tell me that like we have like answer this question. Like why do we need to separate different components of a given mixture here? Why separation is important?
Sir, separation is important because if we don't separate things, we will we get more wastage of time.
Okay, to avoid wastage of time, to save time.
Yes.
Okay, and
we are we will be like it is also for the neatness, cleanness.
okay, to keep the surrounding clean. Okay, that can be taken as one such example, one such reason. Also to separate useful components from a mixture.
Yes.
To get useful components of a mixture. And
Yes, sir.
for like many times we would be like our files would get cluttered together right now, so we have to separate the files and sort them into proper groups for the ease of studying them. So
Yes, sir.
components of the mixture should be separated because some of them are useful to and to save our time, etc. Like we have the example of like you have to remove the tiny pieces of stone from wheat or rice by hand picking. Okay, explain winnowing. What is winnowing? Yes, Salima, what is winnowing? Yes.
Sir, it is a process. Winnowing is a process by the wind, like um,
Like it's the process of separating a heavy component and a light component of a mixture. If
yes.
there's a mixture which has two components, one is heavy, one is light. Let us say that you have some wheat,
Yes.
and you have the seeds of the wheat. The seeds of the wheat is less weighted. It is lighter. It's a lighter particle. This seed is this grain is heavy. So with the help of wind, we'll be separating it. The farmers would be using this to separate the lighter particles from the heavier seeds of a grain. This is called as husk. Like you have a husk. So in order to separate the light husk particles from heavy seeds, we'll be carrying out winnowing with the help of the wind.
Yes, sir.
Okay. Okay, there were other methods of separation also we have learned in that chapter, like about sieving. We have learned about sieving. Huh?
Yes.
Okay, say that I'm giving you a mixture of sand and water. You have sand plus water. How are you going to separate sand and water? Which method of separation?
Filtration.
Filtration. Okay, you can do that, or you can simply do sedimentation also.
Yeah.
Right, and you will allow the mixture to rest undisturbed for some time.
Yes,
So
sir.
the sand will settle down now. Sand will settle down, and the water will accumulate on top of it. And
Yes.
slowly we can pour the water to the next container. Okay,
Yes, sir.
that is one thing. Okay, also answer to me that what is churning and what are applications of churning? CHURNING. Yes, like we have seen that from milk we obtain butter and other products. So that is obtained via which process? Like to obtain cream from the milk, you would have seen that the woman would be taking this pot made out of clay, and they would
Yes.
put a stick in this like this, and they will rotate it with the hand,
Yes.
and the cream will be separated from the milk. What is that process called as?
Sir, even in the when we do the blood test, they'll spin it very round, very
Exactly.
so fast.
They're also like to separate the plasma from the blood
Yes.
and other blood components. So
So
that
that
will
is
be
called
done.
churning, right?
That is the method of centrifugation.
Oh,
Okay, no?
center.
And churning also follows the principle of centrifugation basically.
Yes.
Okay, no? So
Yes, sir.
churning also like basically churning is the process here, na? Like churning particularly is the term used for the milk. uh, so it's the process
Yes.
of shaking the milk in order to convert it into butter or to extract butter from the milk. That is what churning is. Okay, no?
Yes, sir.
Okay. Furthermore, it is based on the concept of centrifugation. So what does centrifugation says? Remember we have learned about this in the class.
Yeah.
What is it? Basically what we know that that many times, let's say you have a glass of milk, so many times some fat particles, you might have seen some fat particles will be floating on the milk. Have you ever observed that some yellow fat particles might be floating on the
Yeah.
milk? huh? So they
Yes,
are
sir.
actually suspended in the milk. They are suspended, meaning that they do not settle at the bottom but they remain suspended in it. Okay. The
Yeah.
centrifugation is the method of separating those suspended materials in a given liquid. So in this process, the liquid will be spun. It will be spun at a very high speed. So what happens? The lighter suspended particles, it accumulates on top. It will accumulate on the top. That is how it works. Got this thing, no?
Yes,
Okay.
sir.
Only you are there in the class, no? Others still haven't joined.
Yes, sir.
Okay, we can do one thing since you are the only one in the class. So you can ask questions from the previous chapters. If you have any other questions, do let me know. Like since I have asked several questions to you, if you have any question, any doubt, please let me know. Yes, Halima. Yeah, Halima, you there in the class?
Yes, sir. I'm.
Uh-huh. Just go through your syllabus. You have the chapter light, then things around us. Light is there, things around us there, and then you have separation of substances, and we have this chapter adaptation also. So if you'd like to revisit any chapter, just let me know. Otherwise, we'll be continuing with what we were doing in the batch.
Sir, can we revisit the chapter light, shadow, and reflection?
Light, shadow, and reflection. Okay, sure. Okay, so we'll be revisiting that chapter. Just give me 1 minute and then we are going to continue. Okay. I'll be sharing my screen in a minute. Okay.
Yes, sir.
You just give me a few more minutes and then we're going to continue. I'm just actually taking the slide, and that's why it's taking some time, and then we'll be continuing. Okay.
Yes, sir.
All right. So let's start the class. So talking about light, what we had learned about light, that it is a form of energy which is responsible for making us to see different things around us, right?
Yes.
It is because of light only that we are able to see different things around us. Okay. By the way, before we continue, let me just quickly give a brief of the different things that we had to learn in this chapter. Okay. In fact, we had done this earlier, but let's revisit this once again. So in the chapter, we'll be learning about few fundamental things. So I'm writing down the topics of the chapter here. Like what is light? We will get to know about luminous objects.
Yes.
And then non-luminous objects. Furthermore, we will learn about on the basis of with how much of light can pass through a given material. We have transparent and what?
Translucent and opaque.
Translucent and opaque
Opaque.
objects are there. Good. Then later on, we'll learn about characteristics of light. What are the characteristics of light? Okay, like how does the light travel? Can light bend and all those things. Then you will be learning about shadow and its properties.
Properties.
What are the properties of the shadow? Then later on, we'll be learning about the pinhole camera.
Yeah.
Pinhole camera, and then we'll be learning about mirror, its uses and its types. And we'll also be learning about lateral inversion in this.
Yeah.
Okay, let's see if we can cover all these topics today. So talking about light, what we know that it's a form of energy which is responsible for enabling us to see different things around us. So when light falls on an object, they say that you have some object here. So when light is going to fall on it, what will happen? Some of
Shadow will form.
shadow will form, while some of the light ray may get reflected. Some of the light ray may get reflected from this.
Yes.
So if these reflected light rays comes to our eyes, so thereby behind our eye, we know that we have a retina. Behind
Yeah.
our eye, we have a retina on which the image of this object will be formed.
Yeah.
Getting it up. So due to the reflection of the light from this object, we are able to see this. So it is reflection which enables us to see different things around us. That is one thing. While what we know that, while what we get to see that light not only reflects, but it can refract also. Say that you have a bucket of water and you might have seen, or just take a glass of water, let us say. And in this, if you were to dip a pencil, this is a glass that is full of water. Okay, Halima, you have taken a glass that is full of water and just dip a pencil in that. You will observe that the pencil will appear to look like this. Have you ever done that?
Yes, sir.
You have? What did you observe?
It was like it was gonna bend.
It,
But then when I removed, it wasn't bending.
it wasn't bending, but because it actually doesn't bend. Okay, na? Why here? What is happening here? Here, refraction is happening. Here, refraction is happening, where the light rays would be bending. The light rays of this is
Yes,
bending
sir.
here. So light rays can bend also when it goes from the air into the water. The medium is changing here. So when medium changes, it can bend also. But that is not the part of the main discussion here. It is because of refraction only that you get to see twinkling. Why the stars appears to twinkle? It is because of refraction. Okay.
Yes, sir.
Anyways, so when light falls on an object, some of it gets reflected, and this reflected light, when it comes to our eyes, we are able to see that object. So some of the objects that will be giving out this light, it could be it could be a torch, it could be a
Yes.
torch, it could be a sun, it can be a candle, it can be even a firefly. Have you seen a firefly?
Yes, sir.
They're although very less to be found nowadays, but they are there. Okay, no?
Yeah.
And there are some other organisms like glowworm also.
Yes.
Okay. Have you thought about like what is it that makes the firefly glow? Why do they glow?
No.
Mm-hmm. Ever thought about this? Actually, they would be glowing because some chemical reaction takes place in their body, because of which a light is produced. Getting it?
Oh,
Some chemical reaction takes place in their body, and in that chemical reaction, light is given off. You might
yes,
have
sir.
seen certain fishes also, that there will be some fishes
Yeah.
that will be glowing. Okay, no? So glowing fishes are also there. We have several fishes are there. We should be glowing. So
Yes.
there also basically a chemical reaction takes place in their body, and in that light is given off. Anyways, so our conclusion here is that there can be different sources of light. So talking about the source of light, on that basis we have two kind of objects. On that basis we have two kind of objects. One is called as,
Luminous and another one is non-luminous.
another one is non-luminous. Very good.
Sir, luminous objects are the objects that produce lights,
Hmm?
like produce light, and non-luminous objects are like they depend on the other lights or they won't produce light.
Okay, so they produce or basically emit their own light.
Yes,
Emit their
own light.
own light. That is the case. So we have the example of like sun,
Sun, uh,
torch bulb,
firefly,
fireflies. Very good.
bulbs, the
Bulbs.
candle.
You missed a very important thing here. You're missing one example. Stars, no?
Yeah.
Basically, sun is one such example of stars.
Yes.
Okay. Now the question is that why moon also appears to be why moon also appears to be giving out light, although it is not giving
Sir,
its own light. Hmm.
uh, because uh, because it depends on sun's light. Like it doesn't have its own light, but
Mm-hmm.
because of the sun's reflection on
Hmm.
the moon, it gives light.
Hmm. Good. What basically happens when we look at the moon? See that here we have the sun. Okay, this is, let us say, our sun, and say that this is our moon. So the surface of the moon is such that the surface of the moon acts as a good reflector of the light. So
Yeah.
whatever light rays will be falling on the moon, it is reflected back from it. And if an
Yes.
object does reflection, that object is visible. That's what we know. If the light
Yeah.
rays gets reflected off from an object, that object will be visible. So same thing happens here also. These light rays get
Yes.
reflected. So that's why they are visible to us. That is one thing. Okay.
Yes, sir.
And in fact, sometimes it can be seen during the day also. Right now, if it is in
Yeah.
the right position in the sky, and if reflects some of the sun's light even during the day, it can be seen. That is one thing. Also, sometimes what we see that eclipses takes place now,
Yes.
right? So that
The
times,
s-
mhm,
eclipse.
solar and the lunar eclipse.
Yeah.
So what happens in the lunar eclipse?
When the moon is in the between of, I mean, no, when the earth is in between of sun and moon,
Hmm.
lunar eclipse will occur.
Lunar eclipse will occur. So say that
Yeah.
this is the sun. Here we have the earth, and here you
Yeah.
have the moon. So when the Earth comes in between the sun and the moon, so what happens?
The sun's
Mhm.
light will get like will get
Obstructed due to the Earth, no?
yes,
The Earth obstructs the light. So what we
light.
know that Earth here acts as an opaque object.
Yes, and the shadow will form on the moon.
The shadow of the Earth will be forming on the moon. So this
Yeah.
is this is the region in which shadow is formed. So this much of
Yeah.
region is not visible.
Yes.
So that is what happens in the case of lunar eclipse. And
Eclipse.
opposite happens in the case of the solar
Solar eclipse.
eclipse, where the moon will come in front of Earth and in between sun and Earth.
Yeah.
Got this now? So hope you have understood this. Okay.
Yes.
All right. Now let us understand about these terms, like what is ray of light and what is obstacle. Read the given paragraph.
Ray of light. A straight thin beam of light from a source to an object is called a ray of light.
So
Obstacle. An object which comes to the path of the light is called an obstacle.
that is an obstacle. So say we have the sun here. We have the sun. Now in mathematics, you would have learned of the term like line, line segment, and ray.
Yes, sir.
What we know that ray has an origin point from where it will be originating, but it doesn't have any end point. It will
Yes.
keep on going in one direction. Okay. So say that this is a sun. Sun is the originating point of this sun's ray, of this ray of light. So that
Yes.
is what ray of light is. Ray of light. So it's a straight thin light which comes from an object. That is what ray of light is. Now if there are several rays of light like this, there is this one ray of light. Now let us say we have several ray of light. 1, 2, 3, so many. So
Yeah.
that will be now called as beam of light.
Beam. Yeah.
This is beam of light. While this was just ray of light, a thin line of light, a thin ray of light here is this. While when there's a group of
Yeah.
ray, that will be called as beam of light. That is
Beam
one.
of light.
An obstacle will be anything that will come into the pathway of the light. An obstacle can be of different types. Okay, now obstacle can be of different types. There we'll get to know that it can be transparent, opaque, and translucent. All of these will be the obstruction in the
Obstacle.
obstacle in the
Obstruction.
obstacle in the pathway of light. That is one thing. Okay. Furthermore, talking about like how the light will be traveling. Hmm. See, what we get to know, like light always travels in a straight line. Like here we have this setup where different cardboards have been placed on this wooden stick, on this wooden board, and the holes have been made on these A, B, and C cardboard at equal distances. And thereby you are able to see. But let us say if I were to block this one, will light pass from it anymore?
Yes.
If I were to block this hole, will light still be passing?
No, sir.
No, right now. Or let's say if the position of the hole were to be changed from here to here. So can light bend like this? Can light was traveling like this? Now can light bend like this? Can it bend like this?
Sir, light cannot bend. Light will be will like light will always be in straight line.
Okay, no?
I mean, travel in straight line.
It always travels in a straight line. So that is the one of the property, and that is called as rectilinear propagation of light. Okay, no? That is one thing. So light always takes the quickest pathway between two points, meaning that for this light to reach from this candle flame to the eye, it has, let us say, two pathway. Like it can go in this direction, and another one is being shown in the diagram. So which one is the shortest and the quickest pathway? The one I have drawn or the one that is shown in the diagram?
Sir, the one which is drawn in the diagram.
The B one, right now?
Yes.
So light therefore takes the quickest pathway, the shortest pathway. So the shortest pathway is the straight line. It's the same as, let us say, you have to travel from your house to your school, let us say, to your school. Say that this is your school and
Yes.
this is your house. So you have two pathway to go there. Like this is the first pathway, this is the second pathway. So the quickest pathway is the A1,
The first one.
the first one, that is A1 now.
Yeah.
So same thing, light also applies. So it will always be traveling in a straight line. Okay.
Sir, if the question says that the light travels in a straight line, justify. So I'm supposed to write yes, light travels in a straight line. In the given there is and one example of light traveling in a straight line. You can take 3 cardboard sheet, pin the
No need to
the
no, see, stop there. No need to explain this whole setup. You simply have to define that light travels in a straight line because it chooses the shortest pathway between 2 points. Light travels in a straight line because it takes the quickest pathway between any 2 points. Okay,
Okay,
now that's why it travels in a straight line. Got this, no?
Yeah.
Okay, that is one thing. Okay. Then talking about how much of light an object will allow to pass through it, or whether it will be even allowing the light to pass through it or not. There are 3 types of materials, okay, now which will be transmitting the light. Okay, like you have this one here. This is a magnifying glass, which is a transparent object. So they allows the light to pass through them. Okay, now so objects can be seen through them very clearly. So you have
Yes.
example of like clean air or clean glass or this magnifying glass.
Yes.
Then you have an opaque object like this door here.
Yeah.
So this door will not allow the light to pass through it, and we can't see
Will,
objects through them.
It will
Block the light, it will reflect the
and
light
it will
rays.
it will make a shadow.
Okay. So that is the case of the opaque object, that it will reflect the light. Light rays will get bounced back from it, and thereby a shadow will be formed in this case. So we have the
Yeah.
example of wooden door, textbook, a piece of rock, or any different other examples. Then we have the case of translucent objects. So these objects will allow only partial amount of lights, only some amount of light to pass through them. So the objects through them can't be seen clearly. Okay, so we have example of this, like tissue paper. You can take example of
Sir,
tissue paper, or like a frosted glass. Yes,
sir, in
Halima?
the translucent objects,
Mhm.
only a beam of light will come or only a ray of light?
No, always a beam of light will be coming. Light, like whenever you look at the sun's light now, or when you look at the light coming from the candle, so there will be lots of beams of light in it. Okay, now it will be traveling in the form of beam. Okay, now for convenience, we take this light ray. Okay, now like
Okay.
say we have taken a light ray, but can you just point out, okay, so this is a ray of light, can you just
No,
looking
sir.
at the air, when looking at the sunlight, you can't point it out. Light
No.
always travels in a beam, and there also why and translucent object light will be traveling through traveling in the form of beam now. So examples of translucent object are tissue paper, a frosted glass, a tracing paper, and like butter paper also. Got this? Okay. Now say that I have provided you with a piece of paper. Usually papers would be opaque. If I want you to make it translucent, what you will be doing? If a piece of
Sir,
paper is
can you repeat?
if a piece of paper is provided to you to make it
Hmm.
translucent, what will you do?
Sir, you can put no wait. Uh,
This is what a frosted glass looks like. See this one.
oh.
Okay, now this is how
Oh,
a
I have
frosted.
seen this somewhere. I don't remember.
Okay, it is basically installed in Windows and in different places in offices. Okay,
Yeah.
so where we would like the light to pass through it, but we wouldn't want that the person should be able to see through the window. Okay, no,
Yes.
light can pass through, but we can't see through the window. So that is what a frosted glass looks like.
Yes, sir.
Okay, yeah. Answer the question, like you have this paper. Say this is an opaque paper. To make it translucent, simply put some oil on it.
Oh.
As simple as that. Yes, Salima.
Yeah.
So just put some drop of oil on this. Now it will become translucent. So hope it is clear. Okay.
Yes.
That is one thing. Then talking about shadow formation. Okay. Before that, there's one more thing. In this, we would like to discuss talking about the characteristics of the light and the properties of the light. So far, we have learned that it travels in a straight line. Okay. We have learned that it travels in a straight line. But will it require some medium? Will light require medium? No. Actually, light
No,
does
sir.
not require a medium to travel. So let me just tell you the different characteristics of light. The first thing is that light, it does not require a medium to travel. Further, we have learned it travels in a straight line. It can be reflected. Also, we'll be learning about the speed of the light also.
Yeah.
The first thing is that light travels in a
Straight line.
straight line. That is one thing.
And
That
light do not need a medium.
okay. So it does not need a medium.
Need any medium.
So what evidence do we have for this? So we get to see that light can travel through vacuum also. Right now?
Yes.
So it can travel through vacuum also, like in between the sun and the earth. Like here we have the earth, and this is say that this is the atmosphere of the earth. This is the layer of air around the earth. But between the atmosphere and the sun, like where the atmosphere ends and where the space starts, this is the sun, and this one here, this is the atmosphere.
Earth. Oh, atmosphere.
Atmosphere, and this is the earth. So in between the atmosphere, like where this atmosphere will be ending, so in between this and the sun, there is just vacuum. There isn't any medium, but light still manages to travel. Light still
Yes.
travels through the vacuum. So that's the proof that it does not need a medium. Okay, and light travels really fast. If you were to talk about the speed of the light, so speed of the light is 3 times 10 raised to the power 8 meter per second. That is 3 lakh kilometer per second. Getting it? So that is the speed of light.
So the speed of light is 3 into 10.
3 into 10 raised to the power 8 meter per second.
Oh.
Okay, now? And in terms of kilometer, light
3 lakh.
3 lakh kilometer per second.
And yeah, okay.
Okay, like in just one blink of an eye, in just 1 second, light will be traveling this many kilometer.
Oh.
Got this? Okay, that is one thing. Okay, that is one thing. Also, light to reach from the sun to earth. For the light to reach from the sun to earth, how much time it takes? Light to reach from sun to earth, it takes about, do you know about this? It takes about 8 minutes 20 seconds. Got this, Salima? So light will be
Yes, sir.
taking this much of time to reach from the sun to the earth. Okay. Now there are a few
Yes, sir.
other properties of light also, like normally what we have learned that light can't be bent. Normally that's what we have learned. But the thing is that light can bend around the corners of very tiny objects. Getting what I'm trying to say? So light can bend when it will be passing from, like what we have learned in the case of refraction. Remember what we have learned here? Light ray are bending here now. But when does it bend? When the medium changes. Okay. So light will be bending when it passes from one medium to another.
Yes, what? Yes, sir.
Okay. No? So that is the thing here. So another property is that light bends
Light bends
when it travels
in a
from
I mean,
one medium to another.
from one medium corner. Okay.
Okay. Now take the case of this one. Let us say that this is a ray of light that is traveling from the sun to the earth.
Earth.
So what is happening here? As soon as it enters the atmosphere, now it bends. Can you spot it here?
Yes,
It
sir.
has bent. So light will be bending when it changes its medium, when it goes in from one to another medium. That
Yes,
is one
sir.
thing. Okay, there are other aspects of discussion in this, like there are some other reasons also why how light can bend, but that is not part of the discussion, so we are not going to learn that.
Yes.
Okay. Okay. Then talking about shadow. So what do we know about shadow? You explain this. When a shadow is formed, what is it?
Sir, shadows form when an opaque object blocks the way of blocks the
Path of light.
part of light.
So a dark portion is formed on the opposite side of the object here.
Yes.
So this dark portion is formed on the opposite side of the
So,
object.
sir, shadow is always formed on the opposite side of the light, right?
Exactly, on the opposite side of the light and on the opposite side of the object also.
Yes.
And there has to be a screen, okay, no, on which it has to be formed. So let us say that there is a table here on which the shadow is formed, and this table is acting as a screen. This is acting as this is the source of light here,
Yeah.
and here this is the opaque object. So an opaque object is blocking the path of light, and thereby a dark portion is formed on the opposite side of the object. That is basically
Yes, sir.
what shadow is. Okay. Talking about the property, let me just define this. What we have done, that when an opaque object blocks the path of light, then it forms a dark portion on the opposite side of the object.
When an opaque object blocks the path of light, it forms a dark portion on the
Opposite
opposite
side of the
side
object.
of the object. This dark portion is known as the shadow.
Exactly. Okay. Now let's understand the properties of the shadow. Like, what are the properties of the shadow? Okay. So talking about the property, the first thing is that this object must be opaque or translucent. But if it is transparent, then shadow will not be formed. So what we know that even the translucent objects can form some shadow. Like say, you have a piece of tissue paper. Tissue paper, it will also block some of the light now. Thereby,
Yeah.
shadow will be formed. Although that shadow will not be very dark, it will be less dark, but
Yes.
shadow will be formed. Okay.
Yes.
So one of the property here is that opaque and translucent, since they both block the light, so opaque and translucent objects will form shadow. That is one thing. Furthermore, we know that this is basically dark in color. Also, it is formed on the side opposite to that of the source of light. So it is formed opposite to
Yes, sir.
source of light. That is one thing. Okay. Also, it gives us some information about the shape of the object, doesn't it? Just look at this one. Just gives us a slight idea. Although just looking at it, we can't say for sure what that object is. Like if you were to have a ball here, that ball would also have given the same shape shadow of the same shape. Getting it, Halima? But we can just get a slight idea about the object,
Yes, sir.
what the shape of that object would be. So it gives information about shape of the object. That is an important thing here. Okay. Furthermore, if the source of light is brought nearer, the size decreases. The size of the shadow increases. Right now, so when when the distance between object and light is increased, what happens? Distance between object and light is, let's say, decreased first of all. When it will be decreased, in that case, what happens, Halima? Yes, you're there in the class?
Yes, sir.
Okay. So when the distance is decreased, the shadow size will increase. Shadow increases in size.
Yes, sir.
But if the distance is increased, then what happens?
Sir, distances increase, then
Shadow decreases in size, no?
yes.
So shadow decreases in size. That is the thing.
Shadow
Okay.
increases in size. Okay.
Now we are going to learn about the concept of pinhole camera, but first of all, just take a look at video. By the way, you would have seen these things like how these little oval shaped
Yeah.
light will
Yes,
be
sir.
visible on the pathway on the ground like this. Take a look at this video.
Have you ever seen light rays coming through the holes of a damaged roof? You'll be surprised to know, as you can see, that the light rays from such holes produce images of the sun when they fall on the ground. Why? Because these irregular shaped holes in the roof act as pinhole cameras. Now, what are pinhole cameras? Let's first construct one pinhole camera and then let's try to understand the principle.
So what we see that many times we might have seen this thing. Also, sometimes from the window also, or from some small hole in the building, a oval shaped structure will be formed on the ground, and that basically is the image of the sun forming on the ground. Getting it?
Now, by definition, a pinhole camera is a simple optical device that forms an image without using a lens or a mirror. That's surprising. Now, let's join two hollow cylindrical boxes of different diameters in such a way that one box can just slide within the other. Now, what do? We make a small hole in the larger cylinder there, and also make two holes in the smaller cylinder, the one inside. Fine? But there is one care you need to take. The inner hole has to be rectangular and the outer hole has to be circular. We now fix a translucent paper, say a tracing paper, on the rectangular hole because that's going to act as a screen. Now, very importantly, these two cylinders must be enclosed so that you can prevent light from entering the larger cylinder. That will mess up our image. Now, use this pinhole camera and try looking at a tree. Surprise! A clear image of this tree can be obtained on the screen if you slide the smaller cylinder back and forth. Now, how exactly did it happen? Let's look at this diagram. The tree is, say, MN. M is the topmost point, N is the bottommost point. The light rays coming from the bottom of the tree, that is N, they pass through the small hole and strike the screen at the top of the axis, N dash. Can you see that? And the light rays coming from the top of the tree, that is M, strike at the bottom of the axis, that is M dash. Now what happens as a result? As you can see, an inverted and also a much smaller image of the tree is what you get on the tracing paper. Remember the tracing paper which acted as a screen? Now the size and contrast of this image, it can be adjusted. For that, all you need to do is slide the smaller cylinder. Also, one more thing, the image depends on the size of the pinhole. The smaller the pinhole, the sharper will be the image, and of course, vice versa.
Yes, Halima. You understood what was being told in this video?
Yes, sir.
So what we're getting to see that this pinhole camera, okay, na, Many times, by the way, this is also called as obscuro also. Camera obscuro. That is also a term many times that is used for this. Camera
Yes.
obscuro. In some textbooks, you might find this term. So it works on this theory of rectilinear movement of the light. Like light rays travels in the straight line.
Linear propagation of light.
Linear propagation of light. Very good. So which basically says that light travels in a straight line. Okay. So this pinhole camera, it generates a inverted image. It generates an inverted and a diminished and a small sized image on this screen here. It is important to understand the construction here. What we did took this box here. There was a small hole done in it, and why that small hole, these light rays entered, and there you had a screen. By the way, you had a screen of film, basically a film screen on which the image was formed here. Let us understand some important things like how does it function. Okay.
Sir, they were saying that tracing paper, so we can use it as the tracing
As
paper
the screen.
like no, like the butter paper, right?
Yeah, we can use that. Okay, no, we can use that as a screen. Okay, so pinhole camera, it's a simple camera. In fact, you know, there was a Muslim person who discovered this pinhole camera, who invented this pinhole camera.
Yeah.
Pinhole camera, if I'm not wrong, it was invented by Ibn al-Haytham. Have you heard of this person, of this Ibn
No, sir.
al-Haytham? Yes,
I'll-
let me. Ibn
I'll-
al-Haytham.
uh,
Okay, no? So he is the person who lived around the year 1000, almost about 1000 years ago. This person was alive. Okay, na? He invented the pinhole camera, and he also was able to explain how an inverted image is formed. Okay, na? So in the field of light, he has worked so many works. So he had done so many works. Okay, na?
yes, sir.
Getting it now. So this person, I think you should know. The name is Ibn al-Haytham. Got this
Yes.
now? So make sure that you remember his name. Okay. All right. Now let us understand about the pinhole camera. First of all, pinhole camera, it's a simple camera that consists of a light-proof box. So this box is made in such a manner that the only place from where light can enter is this hole.
The small hole.
Also, this is called as aperture also.
Yes, sir.
Aperture, and it's a very small aperture, not a big one. Okay.
Yes.
Also, this is a light proof box that from no other source light can enter in it. And there's a film screen fitted here. Like you can take,
Yes.
you can use a tissue paper, like a trace paper can be used there to obtain light, to obtain image. Okay. That is one thing. Furthermore, here what we get to see that the images that are formed here will be upside down. It will be inverted. Okay.
Yes.
Also in the nature also we get to see that like the leaves of the trees now, like there are gaps between the leaves of the tree, like this is the leaf of a tree, these are, and there
Yes,
are
sir.
gaps between these now, there are small
Yeah.
gaps between the leaves of the tree. You might have seen that. Let me just draw this one. Like let's see this gap over here,
Yes, sir.
this gap. So these small gaps between the trees, they will also act as small pinholes. So when the sunlight will pass through the leaves of the tree now, the gaps between the leaves, they also act as pinhole. And these are examples of natural pinholes. And we can see these round images of the sun being formed on the ground. Got this now. So we have some natural pinhole camera also. Okay,
Yes, sir.
that is one thing. So in this, basically the basic principle was that the light rays travels in a straight line, and as it passes through this small aperture, like this is the M, this is N. So this over here will be M, this over here will be N. So an inverted image is formed. We are naming these light rays of coming from the top as M and coming from the bottom as N. And as they pass by the aperture, these light rays will be falling on the screen, and hence a inverted images formed.
Yes.
Got this one?
Sir, in the in this light, shadow, and reflection, there is one more topic, multiple shadow and colored shadow also.
Okay, multiple shadow and colored shadow also.
Yeah.
Okay, we can take up that topic also.